Okay, sure. I have also on Google Classroom, I have uploaded the solution as well. So let's say if you get stuck, you want to have some reference, you can look into that. Okay.
Sure, sure. Yeah, I saw that, but I didn't open the file yet.
Yeah,
So
yeah.
after completing, if
Sure,
I'm stuck, I'll ask you for, I'll verify the solution.
sure, sure. Just one second. Okay, so we'll go ahead with our class next class, where we'll focus
Okay,
on data types in Python. So
sure.
this is very interesting because Python provides with certain unique data types, which when people come from different languages, they find it sometimes difficult to understand what is the difference. But the data types in Python are very easy to understand and they are very intuitive to use as well. Okay, so we'll focus our attention on them. Here, I've got a list of different data types. So we have booleans, which are true or false. We have numbers. So numbers can be integers or floats or fractions or even complex numbers. Okay. Then we've got strings, which are a sequence of characters. Example like an HTML document. So Python does not have single characters. It just uses strings. A single character is just a string of size 1. It has more advanced uh, data types like lists, tuples, sets, and dictionaries. Okay. So just knowing their difference between them and how to use them will be very useful when we go later into the course for data science. There are many cases we'll find that lists are more useful. Some cases where tuples are useful. Some cases where sets are useful. Some cases where dictionaries are useful. So hopefully by the end of this class, we'll know what are the differences and what are the advantages and disadvantages of each of those data types and when to use what. Okay. So even before we start describing what the different data types are, we can talk about two major types of data types. Okay, where we talk about a property called as immutable. So strings and tuples, they are immutable. Immutable means that once you create them, you cannot change them. Let's say you modify them, you will be creating a new string. You cannot modify the same string, neither can you modify the same tuple. Okay. Whereas for lists, sets, and dictionaries, they are mutable. It means they can be changed. So by changed means we can add stuff to them, we can remove stuff from them. At the same time, we can modify stuff that are already present inside. Okay. So we'll just note this difference, and we'll see as we go ahead how this difference plays a role. Okay. Let's start with strings. So strings are in Python, they are very very common. Uh, we use them by putting them into single quotes. Python, we can also use double quotes also. So single quotes or double quotes for Python, it's the same thing. So it doesn't make any difference. And creating strings is very simple. We just take a variable. In this case, we are taking var1 as variable, and we are assigning it this string hello world. When we print var1, we see that hello world is there. Okay. Another thing within Python, or especially within Jupyter notebooks, if you're writing a cell and the last line of the cell is just a variable name, what Jupyter notebook does is it prints the value in the code. When you execute this, it just prints the value. Okay. So just the last variable written as it is without any semicolon or anything, Jupyter notebooks will print it. Okay. But if you're doing writing code in more traditional IDE environments, then to get the answer, you'll have to write the print statement. So you'll have to write something like print var1, and that would print this. But for Jupyter notebooks alone, only the last variable will get printed. In this way, you cannot print multiple variables. You cannot write var1, var2, and so on. It will not get printed. Only one variable written in the last line will get printed as hello world. So here again, we take another variable var2, and we say that we write Python programming into it. When you write var2, it prints Python programming. Okay. So these are two ways of creating strings. Now there are multiple ways we can access elements within the string. Okay. So here we say something like this. Okay, to access elements, var1 has the string hello world. If we say var1 0, then at the zeroth element we get capital H, and it just prints capital H. Okay. So it has a 0 indexing. You start with 0, 1, 2, 3, 4, 5, and so on. Similarly, if you want to access the next element, we say var1 of 1, you get the second element. So here we are using square brackets. Okay, square brackets are generally used for accessing elements within an array or list and so on. So here a string is basically, if you're comparing it with other languages, you could say that a string is an array of characters. Okay. Similarly, when you say var2 of 5, so var2 has this element. We have 0, 1, 2, 3, 4, 5. So we get the character n. Now in Python, you can do both kind of numbering. You can number from start to the end, or you can also number from end to the start. Okay. So start to the end, we know how to number it. Zero, it starts with 0 and goes till the last character here till 11. But this 11th character can also be used as -1. Okay. So if you do var1 of -1, that takes you. So var1 of 0 is the first character. -1 is one back. So one back is basically, since this is the first character, one back will take you to the last character. So that's the concept they use in Python. When you say var1 of -1, you get exclamation. var1 of -5, you say -1, -2, -3, -4, -5, which is 0. Oh, okay. So we can use negative indexes also to help us count backwards. Of course, we get index out of range when you put a number that is very big, which is outside the range of the minimum and maximum boundaries. So let's say var1 has around 10 or 15 characters. If you put var1 got 100, you get string index out of range. Similarly, in the negative side also the same exists. When you put -200, you get string index out of range. Now we can so as we saw when we were doing loops, iterating through sequences is very easy with Python, especially using for loops. So var1 is if it's a string, then a string is also a sequence of characters. So when you write for I in var1, print I will take individual characters of var1. So var1 is hello world. It take individual characters and prints one character at a time till we have finished a string. So that is how we can use this. We can also, so once we have it in character form, we can also use conditional operators. So we again had seen an example of that last time. Here also we're saying if I is equal to L, only print them. So it just prints 1, 2 and these 3 lines. That is why you get 3 L's here. We can also grab slices of a string using this kind of notation. Okay? So this kind of notation is very common notation in many languages. We have it here in var1 in Python. What we're doing is it says that var is the variable string which has hello world. From this we are trying to grab 0 to 2. Okay, so how do we interpret these numbers? Is when you have 3 numbers separated by 2 semicolons, then the first number is taken as the start index, the second number is taken as the end or stop index, the third number is taken as what steps you will be taking from start till end. Okay, so when you don't specify some things, there are different ideas out of it. Okay, so first case, when you don't specify the step point, then it is assumed that you will be taking a steps of 1. Okay, so by default steps is equal to 1. Here when we say 0 to 2, how do we count this? We start counting from 0, take a step of 1, you get 1, you get 2. But the thing with Python is whenever you write the last number is not taken into consideration, or you'll be just counting till 1 less. We saw the same idea in range as well. Okay? So the function range, when you write something like 0, 2, it will count from 0 to 1. Okay, so 1 less than this number. Same idea exists here. So here we will not be counting 2. We'll be just coming to 0 and 1. So when you go to 0 and 1, at 0th letter you've got H, at 1 you have E. That is why this selects 0 to 1, which is HE. So out of hello world, it selects HE. Okay. Similarly, a different example, when you say 3 to 6, it will give us 3, 4 and 5. 3, 4 and 5 gives us, so this is 0, 1, 2, 3, 4 and 5 gives us this space, which is L, O, and space. So that is what we get here. Okay, and we can give a different instance, 3 to 9 with gaps of 2. That gives us 3. If I leave 2 with gaps of 2 means leave 1. So skip 4, take 5, skip 6, take 7, skip 8, take 9, but I cannot take 9 because 9 is the last number. So we get only 3, 5, and 7. If we look at 3, 5, and 7, we should get, so this is 0, 1, 0, 1, 2, 3. 3 is L, 4, 5, 5 is spacebar, 6, 7, 7 is O. So we should get L, space, and 7, which is what we get here. Okay, I hope this notation is clear of grabbing slices from the string. Okay, do any of you guys have any questions at this point?
No.
Yeah, great. Sure. If you have any questions, you can just stop me and then we can discuss on it. Okay. So as I said, there are certain blanks. Okay. So in that formula of start, end, and step, when you leave out certain things, certain notations are assumed. So first, if you leave out step, it is assumed that step is also always equal to 1. Okay. So let's say what happens when you leave out start. So when you leave out start, it is assumed that it starts with 0. Okay. So when you leave out start, it is 0. When you leave out end, it is actually what it says. If you leave out end, it assumes that it is in the end only. Okay. Let's take examples of that. So in this case, we are leaving out start and we are leaving out step, which gives us just colon 2. Okay. Since we have left out start, it assumes we are starting from 0. Since we have left out step, it assumes that we're taking steps of 1. So it will go from 0 till 2 with steps of 1. That is 0 and 1. It will not take 2 because 2 is the last number. So it will give 0 and 1, which gives us HE. Similarly here, it will go from 0, 1, 2, 3, 4, and 5. It will stop there, which gives us hello. Okay, so starts from 0 until the fifth character. If we do this, it will start from 0, take steps of 2, so 0, 2, 4. It will not take 6 because 6 is the last, so it will take 0, 2, and 4. So if you take 0, 2, and 4, it says 0, 1, 2, 3, 4. So you should get H, L, and O, which is what you get here. Now if we leave the end or blank statement, if we leave the last point, then it assumes that it goes till the end. Okay, so if you do variable 1, 5 to end, it gives you so this is 0, 1, 2, 3, 4, 5. So 5 is this point. From this till the end is what it will give you. Okay, and we get that same answer here. Now if you skip out both these numbers, then you have skipped out start, so it will take from 0. If you have skipped out end, so it will go till the end. You have skipped out step, so it will take steps of 1, so it will take the entire string. Okay. So when you want to just end entire string, you can simply write var1, or you can write with this notation, and which also means the same thing. Interestingly, we can do something like reverse also. Okay, so here when you skip out start and end, it will go from 0 till the end with steps of -1. Steps of -1 means it will go in the reverse direction. So in the reverse direction, the first alphabet you get is exclamation, D, L, R, and so on. That is why you get this printed here. So to reverse a string in Python is very simple. You can use, there are multiple functions which we can use, but here even with indexing, you can reverse the string very easily. Okay. So the next major data type that we look into is lists. So lists, like other languages, are arrays within Python, but they are much more interesting. So it can hold ordered collections of items. Ordered collections of items means you can store things in a sequence and it remembers the sequence. There are other data types that don't remember sequence, hence this is important, because in most languages all data types remember sequence. Whereas in Python, there are some data types that don't remember sequence. So it is noteworthy to point that lists, they remember sequence. So when you add items, it matters which one you add first, which one you add next, and so on, because that will be inherent to the running of the program. Okay. Then the list of items should be enclosed in square brackets. So when we write lists, we define them within square brackets, and yeah, so that it understands it is specifying a list. Once you have created a list, you can add, remove, or search for items in the list. So lists are mutable objects. So since they are mutable objects, it is you're allowed to add, remove, and modify items also. Okay. Since we can add and remove items, we say that this is a mutable type. Okay. Let's go ahead. So a very simple example is, let's say here we are creating a variable x, which is the list. This is a list of numbers. So we define that into square brackets, and we individual entities we separate using commas. Okay. So when you separate using commas, you will have this is a list of size 3, having the variable having the objects 1, 2, and 3. Similarly, we can have a list of floating point numbers, and we can do this something like this. We can have a list of characters. So in characters, they're basically strings of size 1. So in Python, we can have lists of strings, and we can have lists of mixed elements. Okay. So most languages, they don't allow that. So C doesn't allow you to have a mixed list. Mixed list is a different data type, whereas in Python you're allowed to have different objects in one list also. So here we have a integer, we have a floating point unit, we have a boolean number, we've got a string, again an integer, string, and boolean, and it can be part of one list, no problem within Python. Okay. List also allows duplicate values. Okay, so here we have 10 repeated twice, we have 25 repeated twice, and there is no problem in lists, and it can have duplicate elements also. It's noteworthy to point this because later in the course we'll see there is a data type called as set, which does not allow duplicate characters. It will allow only single characters.
And I just small doubt.
Yeah, sure.
Is this list is just like matrix? Can have multiple columns also,
Yes, we
multiple
can.
rows also? Yeah.
Yes, yes, yes. We will. So in lists in Python, we don't with the base data type as list. We don't talk about rows and columns. We just talk about multi-dimensional lists. So you can have a list within inside a list. Okay. So when you're talking about matrices, we will use a package called as NumPy for dealing with matrices, where we will be calling rows and columns. Okay, so that will be probably once we finish our basics in Python, we'll go to packages, and within packages, NumPy is something that is more closely related to matrices. Lists are not closely related to matrices. Lists are just yeah, you will know further as we go with more examples and so on. Okay.
Okay, fine.
So like for example here, we cannot have a matrix that can do this. Okay, that will mess up your matrix multiplication and other things. Uh, so there is some differences between lists and how we use matrices. Okay,
Okay, fine.
especially within machine learning, we'll be using a lot of linear algebra for implementation of different algorithms. So those times we'll be using NumPy to represent our matrices. Okay. Going ahead, how do we use lists? So let's say here we have populated a list with elements 10, 25, 12, 38, and 24. To access elements within the list, we can use the same indexing like strings. So x of 0 gives us the first element 10, x of 3 gives us 0, 1, 2, 3, element 38, and that's fine. If you put an index which is greater than the size of size of the list, you will get a list index out of range error. Similar to strings, we can access elements in the reverse order also. So when you say x of -1, you get 24, and that works out as well. You can create empty lists by saying let's say here we initialize with just empty square braces that will create empty lists. Apart from this, we can create empty lists by using the function list with open and close parentheses, and that will also create an empty list. We can update lists since lists are mutable. Let's say here x is this, x of 1 is 25. If we want to update 25 with the value 5, we can write x of 1 is equal to 5. And now when we print x of 1, we can see that this 25 has changed to 5. If you print x, you can see that in the entire list also, we have changed the value 5 here. List assignment and equivalence. So when you compare lists, how do you do that? Okay. So let's say here we are having a list A, which is defined with square braces 2, 4, and 6. Now we are creating a copy of that using list function. So you're creating another variable called c, and you're saying you're creating that by list of small a. When you print a and c, you can see that we c has the same copy as a. Okay. Uh, if I write c of 0, so c of 0 is this element. If I'm updating this element to 10, we can see that a and c, they maintain different copies here. Okay, so c has changed. First element of list c has changed, but the first element of list a has not changed. Okay, in contrast to that, let's see a different example. Here, if I have a created as, so same scene, we are doing it a bit differently. We are saying a is equal to 246 and b is equal to a. When you print a and b, you see that okay, a and b are so and so. If you say b of 1 is equal to 12, so basically you're replacing this 4 with a 12. When you print a and b, you see that both a and b have changed. Okay, which brings us to a very important concept in Python called as deep copy or shallow copy. Okay, so shallow copy is where we have something like this. They seem like two variables a and b, but in the background they are sharing memory. So when they are sharing memory, when you update one element, the other element also gets updated. Okay, so this is called as shallow copy. We'll be coming across this concept again and again within Python. So it's good that we are getting introduced to this concept very early within the course. Okay. A second type of copy is deep copy. So deep copy is something what we did here, where C is a deep copy of A. It means that they don't share memory. So when you update one element, the other element does not get updated. The way you do that is if you just assign a variable by equal to, you get a shallow copy. But when you assign a variable using the base function, so here since it is a list, I am copying list A to C using the function list. This creates a deep copy. Okay. Later in the course, we see to create deep copy, there are other methods in different packages. So we'll be looking into a package called as pandas, and pandas has a different way of creating a deep copy. If we just say, if there are two variables within panda, let's say I have a variable df and df1. If I say df is equal to df1, this will be a shallow copy. Okay, we'll discuss this more in detail when we reach across pandas. But have you both understood this concept of deep copy and shallow copy?
Yes.
Okay, great. So we'll go ahead. Now we can compare lists by something like this. So let's say if I have a list here 246 and a list B 325. If I can compare individual elements. So if I say A of 1, which is 4, is equal to B of 1, which is 2, we know that they are not true because 4 and 2 are not equal. That is why we get false. If I compare A of 0 2 with B of 1 2, we get it true that they are same. If we compare the entire list with each other, we know the entire list, all elements are not same. So here elements being same in both value and in order. Unless that is not true, the lists are not equal, so we get a false here. If we say A is less than B, this becomes true because so A less than B just compares the first character, the first element. So here, since 2 is less than B, it gives us a true. So generally, I recommend not doing something like this because this is very ambiguous what we are trying to do. Okay, so using the results here is also ambiguous. So this is not probably a good coding standard. Further, we can use slices of lists also. So here we have a list that goes from 0 to 10. If we say list, we are taking a slice of this from 1 to 4. So 1 to 4 will count from 1, 2 and 3, which basically gives us this elements which is here. If we say colon 6, that will count from 0, 1, 2, 3, 4 and 5, which gives us this part 0 to 5. When you say 3 colon, that will give us 3 till end. Okay, so it will go 3, 4, 5, 6, 7, 8, 9, 10, which gives us this. If you are looking for a subset like here, 2, 8, 2 will give us 2, 4, 6. 8 will not be included in our list because that's the last number. So 2, 4, 6 gives us this list. Okay, let's go ahead. Further, there are different functions. There are different operators and functions within lists that are inherently used. Let's look at an example. Let's say we declare L1 as so 2, 3, 4, 5 and L2 as this 6, 7, 8, 9. If I do something like L1 plus L2, one would assume what would happen is 2 plus 6 will give us 8, 3 plus 7 will give us 10, and so on. So we would assume that individual elements would be added with each other. But here, when you say L1 plus L2, Python understands that L1 and L2 are lists. So this operator is overloaded to concatenate the list. Okay. So 2, 3, 4, 5 is concatenated with 6, 7, 8, 9 to give us this bigger list with all these elements. Okay. So you have to remember, when you are adding to lists, it will not do mathematical addition operation, whereas it will do a concatenation operation. Okay. When you do 3 into L1, so you could assume that you would get a mathematical multiplication of 3 times 2, 3 times 3, 3 times 4 and 3 times 5. Whereas what Python does is Python creates 3 copies of list L1. So list L1 is 2, 3, 4, 5. You get 2, 3, 4, 5 3 times. Okay. So these are things that we need to remember. With lists, we get these kind of operations.
Elijah, if you want to do mathematical addition,
Yes.
we have
So
to use for loop.
or we use NumPy.
Okay,
Okay.
fine.
So we can use for loop and get what we want. Okay, but it is much more easier when we use, because these mathematical operations are basically operations that we are dealing this lists as matrices, and that is what basically you would mean. So this would be adding to matrices. It would be multiplying a matrix with a scalar. So we can do this much better with NumPy. But as you said, if you don't want to use NumPy, we can do this with for loops and other things. But we'll have to use some additional logic. It will take some more time and things like that.
Yep.
Okay. So
Yeah.
we can do, if you want to know what is the size, what is the length of L1, you do len of L1, and that will give you, okay, there are 4 elements, you get 4 here. Okay. That's good. Okay. So to add elements in the list, there are multiple ways. So let's say here we do 2, 3, 4, 5 is our base list. To add one more element to it, we do L1 dot append 6. What it will do is it will append will add elements in the last value. So we take 5 here, we append this with 6, so we get an additional element here, 6. Okay. Let's say we create a variable L2, which is again a list of 3 elements, 4, 5 and 6. When you do L1 dot append L2, which is a list, will get appended in the last here. Okay, so it will get appended as this, right? So you should note that it will not take the individual elements of L2 and then append it, but it will append the list L2 also. So here what we have is, we have a list L1 which has 1, 2, 3, 4, 5, 6 elements. 6 elements, out of which the 6th element is a list of 3 elements as well. Okay, so append will add items keeping the inherent property of the item intact. But sometimes we don't want that. Sometimes what we want is, we want to concatenate this. So there are 2 ways of doing that. You can say L1 dot extend L2. What that will do is, now this is our new L1. When we extend with L2, the 3 elements gets added here separately. Or we could have easily done L1 plus L2, because we saw that L1 plus L2 actually concatenates things. Okay, so that is another way of adding elements into the list. If you want to add elements in a specific place, we use the insert command. So L1 dot insert 3, 7 will insert the value 7 at the 3rd location. Okay, so 3rd location, so this is location 0, location 1, location 2, location 3 is where 5 is right now. So when you insert 7 there, 5 will be pushed one step ahead, and we will create a new space and we will insert that element here. Okay, so inserting it works this way. Deleting also works as similarly. We can delete using multiple ways. One way is to delete individual elements. You access the element using the index value, and then you write delete. That will remove the element. So in the second location, first we had 0, 1, 2. In the second location we had 4 for L1. When you do L1 2 and delete, the 4 gets deleted. and everything else moves just one step back. Okay. If you want to delete the entire list, we say delete L1, so that deletes the entire list. Now when you write L1, it says that okay, L1 is not defined anymore because we just deleted it. Let's start creating with a new list with L1 with 1, 2, 3, 4, 5 so that we can test more things. If you do L1.pop, what it does, it takes the last element and it removes it from L1. So now two things, when we remove it from L1, if you capture it using a variable here, this last element, so in this case 5, will get popped into the variable x. So when you write x, we can see x has become 5, whereas now L1, the last element 5 has been removed, so you get 1, 2, 3 and 4. Okay, so pop, when you don't pass any parameter inside, will always remove, it will always pop the last element. Okay, but when you provide a number here, so it will use that as index. So here this is the new L1, pop 2 would be 0, 1, 2. So basically we are popping this value 3. So we'll say x is equal to L1 pop 2. So x will have the value 3, and when you see L1, 3 will be removed. So you'll have 1, 2 and 4 alone. Apart from popping, we can remove elements also. So remove elements, you have to specify what element you want to remove. See, pop is working on index location, whereas remove is working on value. Okay, let me note this down. So pop uses index location, whereas remove uses value. Okay. So if you know what value you want to remove, you probably don't know where it is located. So in this case, it is very small. The list is very small, so it is okay to explore this. But in data analytics, we'll have lists with huge number of values. Okay, somewhere like thousands of values. That time you cannot remove things by location, especially if you know what you are removing. Then we'll use the remove statement. So the remove statement takes a value. When you say remove 2 from L1, this element 2 goes away. So you're left with 1 and 4. Similarly,
Elijah, can we pass? Sorry, can we pass multiple variables inside, like remove 2, 3, something?
yeah, I don't know. We'll have to experiment and see. So maybe note this point. Before ending the class, I'll host a notebook, and then from that notebook, we'll try this out and check.
Yep. Okay.
Uh, Further, if you try to remove an element which is not present in the list, so let's say 5 is not present, when you say remove 5, it gives you an error, says that it is not in the list. Then we can do some basic functions with list. We can find its max value. So you can just say max of L1 gives us the max value. If you can find the min value by writing the min function. So min of L1 gives you minimum. We can write sum of L1 to add all the elements. So it will add everything inside and give us the answer. If you want to count how many times we have a certain element, so let's say we are doing L1 dot count 8, it will count within this list how many times it is repeated. So it is repeated once and twice, so it gives us 2. L1 dot index 8 will return the index of the element, so it will return the first index of the element. Okay, so index 8 says okay, index is found in log 0, 1, and the first location 0, 8 is found, so it gives us 1. When you do index 8, 2, 5, it says that what it will do is find the index of 8 starting from 2, and ending to 5. Okay, so search for 8 within 2 to 5, and what do you get? So that is where we get this index location. So this is 0, 1, 2, 3, 4. That is why it returns 4. Okay, so few things probably to note is here we are using max, min and sum as functions independent of L1. That is, these functions are generic functions to which we are passing the list L1, whereas count and index are functions that come because of the class of L1. So L1 is a list, and the class list has some inherent functions to use. So here count and index are these kind of functions that they already understand the context that we are talking about L1. Whereas here max, min and sum, after passing the list, it is probably it is what do you say? It is an overloaded function which understands what you are passing inside, and based on that it works on that. So these are just minor differences to note, but probably will be useful later on. So we can do multiple things with list. You can sort them, sorting them using multiple ways, using sort and sorted, and we can reverse them also. So let's say he start with L1 to 52497. When you sorted of L1, so it will just sort the list. It will give us 24579, and that's right. Uh, and when you sorted this, the sorted answer gets stored into L2, and L2 is sorted, but L1 is not sorted. If you wanted L1 to be sorted, you could write something like L1 is equal to sorted of L1. So this is a way where without sorting the base list, we can still get the sorted result and store it somewhere else. But if you want to sort L1 itself, we can use the class function dot sort. So if you do L1 dot sort, L1 inherently L1 is the object of this function, and it gets sorted. When you see when you print it out, you can see that. You can sort it in the reverse order. So sorted in the reverse order means you're sorting it in the descending order. Okay, so reverse is equal to true. Descend, sorted from 9, 7, 5, 4, 2. A different example here, we have a different list L with 77, 55, 88, and 11. And when you do L dot reverse, it reverses the order. So it is not reversing, it is not sorting it in the descending order, but it is reversing the way we are accessing elements. So 77, 55, 88, and 11 becomes 11, 88, 55, and 77. So maybe an interesting thing to note here is as a general tip within Python. So Python by default is so popular and so easy to use because it comes with a huge package of inbuilt functions. And if you don't have inbuilt functions, you can move to libraries and get libraries and use those libraries as as functions for anything that you want to do. So if you're writing a code where you're doing a lot of programming by yourself, then you're probably misusing Python. Okay, so Python is known for not so you don't have to program a lot with Python, but you just need to know which packages to use, what functions they have, and just use them. So that is one of the reasons why data scientists love Python so much, because then you can focus more on the data analysis part and less on the coding part. Okay, let's go ahead. So membership operations. So let's say here we've already seen this, but let's say we can go through this again. So if L1 is a sequence here of elements 2, 3, 4, and 5, when you do for I in L1, so what happens is this notation, just as we saw for strings, it knows that L1 is a sequence of elements, and it will take individually one element at a time. Okay, so that's why the for loops are very useful in Python. So here we say for I in L1. So when you print I, it will take individual elements of L one at a time. Okay. We can also check if a certain element is there in the list or not using the in operator. So let's say L1 here has the element 4. If we say if X in 4, so you don't. So here to check if 4 is there in L1, you don't have to do like normally in any other language you would have to run a loop through L1 through all the elements of L1 and keep checking if that element is equal to 4, and when is equal to 4, then we have an if statement there. Whereas in Python you can simply write if X in L1, that is if X is present in L1, then we do something, there is an if condition. If it is not, there is an else condition. We're basically printing the values here. We can have nested lists also. So nested lists are a bigger list having inherent lists. So here list X has two elements. The first element is a list of 3 elements 2, 4, and 6. The second element is a list of 3 elements 3, 2, and 5. We can access them like this. So let's say for example, if we say for I in X, so I will iterate 2 times. For the first time it will take this value. So when you print I here, it takes this value 2, 4, 6, it gets printed. Second time it takes the value 3, 2, 5. Now for every value in I, we are running another loop. For j in I, print j. So j will take individual elements of I, 2, 4, 6, and it gets printed here. Similarly here it prints 3, 2, and 5. Okay. Now we can also have a much complicated list here. So here we are having list y, which is made up of multiple elements. So here we have another list starting here. So it has element 1, element 2, element 3, it ends here. Then we have second element starting here, which has two elements, 3, 2 and 5, it ends here. Okay, that is what we get here. Now to update element 6 of list x and y. So to update element 6 of list x, so element 6 of list x is here. Its index would be 0 comma 2. 0 is for the first element here. 2 is for 0 1 2, the second element here. So x of 0 comma 2 gives us 66, and if you want to replace that, uh, x of 0 comma 2 is actually 6, and we want to update its value, so we update it with 66 by doing this. Now when you print x, we can see that the new value is updated. Okay. Similarly, going down here, we have 6 at this location. To update this 6 value with 66, you have to go to list z. So in y, this is element 0. Within element 0, this is element 0 1 2. Within element 2, this is element 0. So you say 0 2 0 is 66. That updates the value of 6 to 66. Okay, I hope this is clear, right? Okay. So let's go ahead. Now we can split strings in list as well. So let's say we start with the string here. This is a sample string. This is a sample string example, and we do a function called as s.split. And what s.split does is, by default, it takes the separator as spacebar, and it separates this string into a list of individual strings. So this is a sample string example, becomes a list of individual strings. This is sample string example. Okay. Now we can also do something like this. So here, if you pass parameters inside, the first parameter is the separator. The second parameter is how many splits we want. Okay, what is the maximum number of splits it has to do. So if we say specifically that the separator is a spacebar, and we want to split maximum 2 number of times, so it finds the first spacebar, it splits this into an element. It finds the second spacebar, it splits this into an element, and our number here is done. So it takes everything else and puts it as the last element here. Okay. If we have something like this, we can also split it using a comma. So here we are doing string 10 20 30 40, split it using a comma. That gives us 10 20 30 40 as string elements. Okay. Similar to splitting strings, or in contrary to splitting strings, we can join strings using an idea like this. Here we have L1 as a list of string elements, and when we do join, so join works this way. So we have to first give it this character, which will be the separator that will be used while joining, and then an iterable that we'll be joining for. So here we are providing the character that will be used as separator, which is a spacebar, and spacebar dot join elements of list L1. So list L1 is sample string example. This combines us to give this space is space sample space string space example. Okay, so this is exactly opposite of what we were doing with split. So it is not necessary that we have to join using a spacebar always. In this case, we are joining with a hyphen. When you join with a hyphen, it just takes the elements of the list L1 and joins them with hyphens. Okay. Now this iterable can be a list, it can be a tuple, string, a dictionary, or a set. Okay. So we'll look into what the others are. Probably, I think we will just be finishing list in some more time. There are other interesting things that we can do with lists. So in Python, there's a very interesting idea called as list comprehension, which is one of the very powerful tools within Python. Which, simple things you can do with just one line of code. So let's take an example. Here we have an example where numbers is a list of 1, 2, 3, and 4. Squares is an empty list, and we want to populate squares with the squares of these numbers. So ultimately, we are looking to make squares as 1, 4, 9, and 16, which is squares of 1, 2, 3, and 4. So to do that, we can do multiple ways. One is we can write a for loop. We can say for n in numbers. So numbers is this list. N in numbers will take individual numbers. We are running through this loop. We are saying squares.append. We started squares with an empty list. When we do append, it will keep adding in the last. N will take different values of list numbers. and we are just doing the square and appending them into this variable squares. Okay, so this will get this done. But a different way in Python is something like this. If we have a numbers as a list, we can do something like this. Okay, so here the first square bracket and last square bracket says that whatever answer that I get from this has to go and create a new list, and this new list will get populated into squares. Okay, so remember this two squares are important. They say that the answer will be interpreted as a list. Now what will be the answer? The answer will be elements of the type n square. Okay, elements of the type n square will be populated into this list. Now what is n? Okay, so n will be taken from this part. It's saying that n is basically individual elements of this numbers list. Numbers is a list, and will take individual elements of these guys. Since it is in a for loop, it will take individual elements successively, and what will return is square of those elements, and square of those elements will go into this list square. So list comprehension can do, all that we did with this for loop can be done with this one line of code. And when you print squares, we see that, okay, now we have our answer 1, 4, 9, and 6. Okay, so some initially, like for me also, it was a bit difficult to use this successfully. I would always default to writing for loops because that was more intuitive, and that is what we have been doing earlier. But Python gives us more powerful things. So with time you will find, I hope that this will become easy for you to understand and implement, because it saves us some lines of code. It makes the code a bit more Pythonic. Okay, so yeah, just a note. So list comprehension can do even complicated things. So here in the last case we just had a very simple part done, but let's say we want to do something like this: find the common numbers from two lists using a for loop. Okay, so list A and list B, what are the common numbers? The common numbers are 2, 3, and 4. Okay, now to do that in using list comprehension, we would write this. So the square brackets here says that whatever will be returned will be coming into a list. What will be returned? So elements of the type A will be returned. What is A? So A comes from this expression. This expression says that A will take values in the list A. So from the list A will take values individually, which is 1, 2, 3, 4. And if A is there in list B, that is what A we got from here is also a part of list B, then we will return that A. Okay, it's a bit complicated at first to see, but once you get a hang of it, it is very simple to use such kind of operations. Further, we are writing combine different numbers from two given lists. Okay, so two given lists, we want to combine different numbers. So here the combinations would be 1, 2, 1, 7. 2, 2 will not combine because they are not different. 2, 7 will combine. Then 3, 2 and 3, 7. So this is what we look for in our answer. Okay, so to return that, we are writing this list comprehension. So we're using something that we have not defined earlier. So we are using a tuple here. Okay, so tuple is given in parentheses, but for the sake of this example, tuple is not important. What's more important is how we are doing list comprehension. After this example, when we go later into tuples, we'll know what it means. Okay.
And I just small doubt.
Yes.
Common number, why for loop comes first and if loop second? If it comes reverse, also it will work.
Okay.
Like A, if A in list B, for A in list A, like that if it comes.
No, it will not work that way, because so you have to remember the order of how things are working. Okay, so if A in list B is okay, what he's saying is if A in list B for A, so for A in list A, yeah, it's a bit difficult. So basically that would be interpreted something like this. Okay, so maybe what you can think is, whenever you write some piece of code, what will be the underneath this, what code would be written. So if you're doing something like this, if A in list B, sorry,
Okay,
okay.
I think I got. Once when we write another codes, first we write for loop, then only we write if loop.
Exactly. So if you write if A in list B, and then you write for B, for A in list A, It doesn't make a lot of sense because what is there inside,
Yeah,
right?
yeah, yeah. Okay,
So
okay, okay, okay. It's clear.
yeah, okay. So here we are returning elements of the type A comma B, and where do A comma B come from? So A comma B come from this condition. What is this condition? It says for A in list A, for B in list B, if A is not equal to B. Okay, so we're writing three. So here we have a nested loop basically. For A in list A, for B in list B. So A comes from all the elements of list A, B comes from all the elements of list B, and if A is not equal to B, that is if when it is true, then we'll be returning elements of the type A comma B, and that will basically combine different elements that we saw here: 1 1 1 2 1 7 2 7 3 2 and 3 7. Let's go ahead. So that finishes our first data type. We'll go to the next data type called as tuple. So tuples are basically used to hold together multiple objects. Okay, so they are very similar to lists, but there are multiple reasons here. So if you remember when we talked earlier about immutable objects, so tuple is an immutable object. So once it is created, you cannot modify them. You can access different elements, but you cannot modify a tuple. Okay, and tuples are usually used in cases where a statement or a user-defined function can safely assume that the collection of values will not change. So if you want a collection of values that should not change, we generally use a tuple. Whereas if you want a change values that may change or can change, we use lists. Okay? Tuples can be defined uh, using these ideas using parentheses. So here we are defining a tuple T1. We are giving the values 5, 4, 3, 5, 4, 2, 6, 7. And when you print T1, we can see T1 gets printed, and it gets printed with these parentheses values. If we look at the type of T1, we can see the type of T1 is a tuple. Here we are creating another tuple T2, and if you see in T2 we are not passing these parentheses. So even when you don't pass the parentheses, uh, by default it assumes it to be a tuple. Okay, so for a tuple, if you don't pass a parenthesis, it assumes a parenthesis is there. When you print T2, you can see that it has interpreted this with parentheses, and the type of T2 is also a tuple. Okay, so this statement in most languages would be an error, right? It seems like you're taking T2 and you're assigning multiple things within this. Okay, so here in Python, this is not an error, whereas this is a different data type called as tuple. We can have, okay, if you have a single element, so let's say 5, and then we define it as a tuple and put it inside, we see that it does not get defined as a tuple, but a single element takes as the base form whatever this element is, whether an integer or string or list or so on. Okay, when we define it with 5 comma, that takes it as a tuple, saying that okay, there if you want a tuple of single element, you have to do it with a comma, and then 5 gets interpreted this way, and the type of T2 is a tuple. Now tuple manipulation, if you try to manipulate them, what happens? So we already saw that tuples are immutable. Let's say if I have 5 4 2 6 7 as a tuple, and we say that T1 of 2 is 0 1 2, this element, if I want to change that to 4, you get a type error saying that tuple object does not support item assignment. Okay, but it supports accessing items, so you can access them in multiple ways, exactly same ways as you access as lists or strings. So we have a tuple here of elements 5 4 2 6 7 8 9. If we do T2 of 2, it gives 0 1 and 2, that gives us 2. T2 of minus 1 gives 9. T2 of 2 to 5, which is 0 1 2 2 3 4, it will give us 2 6 and 7. Similarly, T2 of 2 5 2 will take values 2, skip 3 4, yes, 2 and 4. So 2 and 4 are basically 2 and 7, that is what you get here. We can say T2 of colon 2, that is start from 0 and give the first two elements, which is 5 and 4. Then we can do 2 comma 2 colon end, which is nothing, which says 0 1 2. From this 2 go till the end, which gives us 2 6 7 8 9. So exactly as lists, we can access elements within a tuple. We can have nested tuples. So here tuples can also have different types of data types. Okay, so here we have a tuple which has an integer, a string, a float, an integer, and then another tuple which has two integers, and that is allowed. If you look at, if I run this through a loop, so tuple is also a sequence, so you can iterate over a tuple as well. Just like you can iterate over a list and string, you can iterate over a tuple. You can write for I in T1, print I comma type. So here we are printing individual elements and its type. So we can see integer, string, float, integer, and tuple. We can unpack tuples. So tuple unpacking is very interesting. So let's say we start with T1 here, and T1 is this, this tuple. If I do something like this, I1, I2, I3, I4, I5 equal to T1. So we are unpacking this tuple. What will happen is T1 will break down into this individual components. Okay, so T1 individual components will have 2. So I1 will take 2, I2 will take B, I3 will take 3.2, I4 will take 10, and I5 will take this last tuple 4, 2. Okay. We can also break this down further. So I5 is already a tuple. I can write I6, I7 is equal to I5. So I5 will break down into two elements. So we'll have 4 going in I6, 2 going in I7. Okay. Tuple unpacking is also applicable to loops. Okay, so let us see an example of that. So let's say here we have a list T1. T1 has multiple tuples. First tuple is 2, 3, 4, 5, 6, 7, and 8, 9. So we have 4 tuples within this list. If I do something like this, if x comma y in T1. So when you write a for loop with in T1, T1 is the sequence, and whatever we have put in here will take elements from this sequence T1. So it would take the first element 2, 3, second element 4, 5, third element 6, 7, fourth element 8, 9. Now when we are writing this element, we are writing it as tuple unpacking. So instead of writing just one value here, iterator, we are writing two values, x comma y. So this tuple 2, 3 will break down into values. 2 will go into x, 3 will go into y. Okay. So now when you print inside, you can see that individually you have access to all elements. Okay. Now this code will generate an error. You cannot just take one tuple and break it down into a loop. Okay. This has to be a list of tuples. Only then this idea works out. Otherwise, this idea does not work out. Okay. Let's look at some examples. If I have A as 10, B as 20, we print A comma B, we get 20 comma 20. But this is very interesting. Here what we're doing is we have A as 20, A as 10, B as 20, and we write this statement here: A comma B is equal to B comma A, which says that take the element B, put that into A, take the element A, put that into B. So we are swapping two elements in one statement. Once we swap it, we can see that A has now become 20, B has now become 10. Okay. This is very interesting because any other language does not allow you to do something like this. Okay. So I remember when we were doing engineering, we had a subject called as C, and swapping two numbers would be one of the initial codes that they would give you for practice. Okay. Whereas in Python, this is so simple. It's just a single line code. A comma B is equal to B comma A, which will swap two elements together. Okay, so let's see further. To concatenate two tuples, what we can do is, let's say A is a tuple 10, 20, 30, B is a tuple 20, 40, 50. We are creating a new tuple C, which will be made from A plus B, and A plus B will basically concatenate two tuples. Okay, so 10, 20, 30, you concatenate that with 20, 40, 50, that will go into C. So remember here, this seems like we are doing we are muting or we are using the tuple as a mutable identity, but you see A and B are not changing value. The final result goes into a new value called as C. But if you had done something like A is equal to A plus B, you would get an error. It would say that tuples are immutable. Okay. Another interesting data type is sets. So sets have certain values. So let's say here we have a set. A set is defined with curly braces. So these are very similar to sets that we study in maths. Okay, when we go to examples, you will know the difference. Here we have a set with 3 elements. So 3 elements are 3 strings with 3 names: Swapnil, Vishal, and Pranay. And you see here that something else has happened, right? So their order has changed. Okay. So one thing you should note is sets are unordered lists of elements. Okay, that is, their order does not matter. So Python has the right and the the authority to change item orders if depending upon whatever conditions they have inside, probably to save space or something else, or to order things in the RAM. Python does not guarantee that when you put things into a set that the order will be maintained, because they are by definition they are an unordered list of elements. Okay, when you look at the type of X, we can see it is a set. Here we are creating a set with 11, 22 and 11. So we are putting 3 elements, but we have a duplicate here. When you print C set, we see that it has taken only 2 elements. It has eliminated the duplicate. Okay, so a set is it can contain only unique elements. You cannot have different elements. Okay. Now, when you do C set 1, it gives us an error as indexing, which totally makes sense because indexing can only work out if you have an ordered list. But when you have an unordered list, there is nothing called as an index. Okay, so you cannot access elements using C set 1. Okay, there are interesting things that you can do with sets. So you can create a new set using the function set with with parentheses. So this is a function called set which creates an empty set. We can create a set with elements using the same function. So here we are saying set, we are passing a tuple of 3 elements 2, 3 and 4. When you look at set 2 S2, we can see that it has made it into a set. We can know that this is a set because it is separated in curly braces. When you check the type of S2, you can see it's a set. When you do S2.clear, it will delete or it will remove the elements from the set. To add new elements, we do something like this. Let's say we start with a set S1 with 2, 3, 4, and we do S1.add 20. It will add the element 20 within this set. So now we have 2, 3, 4 and 20. If we try to add multiple elements, let's say add 30, 40, it gives us an error. It says add does not work that way. It just takes one argument. If you want to add multiple things, we will not use the add function. We will use the update function. So the update function takes a tuple as input. So with the tuple as input, you can add multiple things inside, and all of those things will be part of the set S1. Okay. So to delete elements from a set, we can add elements from a set because sets are not immutable. So they are immutable objects. Okay. So here I have S1 as 2, 3 and 4. If I, okay. So we have reached 8 o'clock. We have finished 1 hour. I think what we can probably do is we can finish sets and then we can stop the class. Is that okay if we go for another maybe 10 minutes?
Yeah, it's fine.
Okay.
Okay, great. So here to remove elements from class, we can do s1.discard 2. What that does is, let's say here we print s1, so we can see s1 printed here gets 2, 3, 4. When you do discard 2, it will remove 2 from the set. Now when you print s1, we can see we have 3 and 4. If you try to discard 20, it still works out because 20 does not exist, but it does not give you an error. Okay, so in the final list you will not have 20 because you never had 20. Okay, so discard will remove elements out of the list but without giving an error. Okay, other way to remove is using the function remove. We can use remove 2 and we see 2 gets removed. When you do remove 20, it gives us a key error saying that 20 does not exist. Okay, how can I remove it? Or we can remove using pop. So if you do 2, 4, 2, 3, 4 and print s1, when you do s1.pop, one element in the list gets removed. So here 2, 3, 4, when you do pop, 2 has gotten removed. Okay, the first element has gotten removed. So again, I would recommend if you want to remove things, either use discard or remove. Don't use the pop, because by intuition, as pop works on other elements, we assume that pop will remove the last element. Whereas for sets, there is no concept of last because sets are unordered. So what pop will remove is something that we don't know. It can be, it can be something from the start, something from the end, something from the between. Uh, Python does not guarantee. So if you're using sets, try to avoid using the pop function. Stick to either discard or remove. Okay. Now,
Like when we use discard and when we use remove, both are exactly same or any difference?
so if I want to remove, if I want to delete elements without giving an error, I will use discard. If I want to delete elements, only those elements that I know are present within the set, then I use remove. Okay. If I have no idea if that element exists inside the set or not, it is better to use discard.
Okay, if we you want to check some null, we do discard. Is that the way?
Yeah. Yeah. Probably.
Yeah,
Probably.
got that right.
Okay. Yeah, that's good. So let's say if you have to write a program to remove the duplicates from this list. Okay, so this list has 23. 23 is repeated. Let me see. 20 is repeated 1, 2 times. 33 is repeated 1, 2 times. 45 is repeated twice. And then 67 is repeated twice. Okay, so if you want to remove the duplicates from this list, can you give me a one line code for doing that? Okay.
Not getting.
Okay, so we can do that very easily by converting this list into a set, because we know sets have unique elements. It will not have duplicates. So I can have S is equal to set of L, and that would remove all the duplicates. What I will be left with is unique
Oh.
elements from L, right? So it's very easy to do this in Python. Yeah, probably today we will not have time to look this in code. Maybe in the next class we can look at code and we can see this works out. You can try it on your own as well. Now, the main power of sets come when we use Boolean operations with sets. Okay, so sets are like exactly how we would use Venn diagrams. Okay, so let's say here we have two sets: A with elements 11, 22, and 33. B set with elements 12, 23, and 33. Okay, so when we do union of A and B, we will get everything: 11, 22, 33, 12, and 23. To do union, we will use a single pipe command, a single pipe, which is also the OR command that we use. So it can be set as A or B, or union of two sets. Okay, we can do union using the dot union command as well. So A set dot union with B set, that will also give us the union of these two items. If you want to use intersection, the intersection will say from these two sets, whatever is the common element, that will be returned as intersection. So that can be done using A and B, or we can use A set dot intersection with B set, and that will give us the unique element. This will give us the common element as well. We can do a difference. So a difference is something like this. So from A, if you remove B, then you would be left with this space, okay, of 11 and 22. So if you do A set minus B set, you get this. You can also do A set dot difference with B set and get this part. But if you want something different, okay, if you want a symmetric difference is if I have two sets, from the union I subtract the intersection, that is a symmetric difference. To get that, we will use a set, this symbol hat, a set hat b set. This hat symbol is generally used for XOR in languages like C. Okay, so here we are doing we are doing a symmetric difference. Okay, so symmetric difference is basically considered union minus intersection. There's a symmetric difference. Yeah, so I think we can stop here. Otherwise, it will be too much to handle in a given class. You can start working. So I've also uploaded the assignment corresponding to data types. So up to what we have covered till sets, you can answer. You can try solving those examples. Probably you can skip dictionaries. We will do dictionaries in the next class. And yeah, that is the last item here. And since this is less, in the next class we can continue with dictionaries and then move to the next topic. I think the next topic is functions, if I'm not wrong. Do you guys have any questions before we stop?
I'm good.
Okay. So we will have next class on my Monday morning. Is that okay? Srinivas, is that okay? My Monday morning would be day after tomorrow for you. Okay. Anyways, I'll share it as an event on the Google Calendar, and then
Yeah, that would.
yeah, great,
Sorry.
sure.